All right, welcome everybody to another episode of the Puget Systems podcast. This week we're joined by machine learning extraordinaire, magnifico, Harrison Kinsley, also known as sentdex, pretty much everywhere online. I think I noticed that was you had a good handle on that. All of your social medias, sentdex. Scientific computing expert, Python programmer, epic garage haver, like that is really cool looking. There. Welcome and thank you for joining us today, Harrison. I always like to, just in case anybody doesn't already know who you are, go ahead and give yourself a little intro, who you are and what you do.
Yeah, sure. I imagine the crazy thing is like, I'm on YouTube. I have a lot of subscribers, but like YouTube is so huge now that like even at like 1 million subscribers, like probably most people don't know who I am, like it's crazy. And there are like, I run into like other YouTubers with millions or even 5 million or something. And it's like, man, I've just never seen that channel before, but anyway, about me, I've been programming. I started programming in like junior in college, and that was all nice. Like self-taught. I went to college for, first it was criminal justice, and then I decided I didn't really know what I wanted to do with that. So by then I'd already like finished all my core curriculum stuff. So I just ended up double majoring in criminal justice and then philosophy. And then somewhere like I think junior year of college, I started to program, and I was like into finance. And I thought I was, like lots of young 20-year-old men, I thought I was like really smart and I could definitely run the finance world. And so I wanted to I started off trading, and then I like realized like all my trading was done on like, I would like read news articles and stuff like that. And then I started thinking like, man, what if you could just like automatically read news articles and then somehow like generate, the term is sentiment. I don't know what I thought the word was back then, but like some sort of like mood or feeling around like companies. And then if you could do this like over time, it would probably be relatively a good predictor of stock prices over time. Sure. And so like I wanted to do that, but I didn't know how to program. I had tried to program like earlier years in my life, and I just never really had like a reason, like a really good reason to do it. Like I just thought it sounded cool to be a programmer. So I just like never had like a goal, or a project. And then so finally I came up with this, and then realized like I need to learn how to program. And I was like asking around like people other programmers and stuff. And one person pointed me towards this package called NLTK. It was like, I think it's Natural Language Toolkit. Okay. And this just happened to be a Python module. And so, and they had like, I think it's probably still active today. It's like NLTK, I think it's .org. I can't remember. And then it's like /book. And that's how I learned Python. I went through their book, and it was just really fitting because it was like I was learning Python. There is like a first chapter about some of the basics, but it didn't get advanced into Python. I don't think there's any object-oriented programming, none of that. It was just like, here's some really quick basics just so you understand, like, here's a string, and like, this is what a string does. And then it pretty much just jumped into doing natural language processing, which is what I wanted to learn about. And so, yeah, so that was kind of like my first project, my first thing to get me into Python programming at all. And yeah, it's actually, I always feel like I started programming like 6 years ago or so. Okay. And then I just realized today that, or not today, like this week, I think that, I'll have been on YouTube sometime this year. I think it's in December, like for 10 years. And then I basically started programming at the same time. So, as I was like learning to do natural language processing stuff, I would like do Google searches and YouTube searches. And I liked like the video format because you could like if someone's going through it live on a video, you can be almost 100% certain that if you follow those steps, it will work because you just saw it work on their computer. Yeah. Or like text-based writes all the time fail you because you'll be going through some change has happened or whatever, or they forgot a step or something like that. So I really like the video format. But then I kept finding that like people would like make tutorials almost like for somebody who already knew like the content, like they were trying to impress people who already knew. Sure. And it just like they would use words that I don't know what that means. Like what's an attribute? Like I don't know that word, Yeah. And so there's like so many like little basic stuff that I just felt like people were glossing over. And then so I just thought, well, as I'm learning to do like NLP stuff, I bet there's lots of people who want to be able to like read text files and read CSVs and all this kind of stuff. And so I just started making videos basically like how I wish people had made videos while I was trying to learn that thing. And somehow that turned into YouTube being basically a full-time career. The sentiment analysis stuff, like that still kind of runs today, but really that ran all the way through 2020, and like actually sold like the indicators basically to like hedge funds and traders and stuff. And like,
congrats. That's
somehow,
cool.
that first project actually panned out to be pretty good.
Yeah.
But then I also found out I don't really like working in finance either. So, but yeah, it's been quite the experience. And yeah, I think programming, and there's lots of stuff that are kind of like programming, but I feel like with programming, like everyone builds on top of each other, and like everyone is willing to like share, you know?
Oh, yeah.
And I think that's like this, just, I find that very attractive, you know, to a field that does stuff like that.
Mm-hmm. Yeah, I've dabbled with a bit of software development myself. Early in high school, or the last 2 years of high school, I took computer science classes and did really well. But I think like you, like I didn't want to go right out of high school working for accountants and stuff. That was only like the career people that they ever brought in were, you know, stuffed shirt, pencil pocket kind of guys. And I'm like, I don't want to work for these people. Like I kind of got into this to make video games, but that's a whole nother thing. But yeah, I like that too, that the community of software development and programming in general is very open to exchange of information and things like that. There's rarely a case where you're the very first person to have ever run into the problem or trying to do the thing. And yeah, I like that a lot.
And like all the software that's just shared, you know, so like even like tech giants are sharing software that comes with a very open, you can use it commercially licenses like TensorFlow and stuff, like where else is that happening? I mean, like I can't think of a field where technology like that is being released, like where I don't know how many hours like went into and still continue to go into the development of like TensorFlow and Keras, or even like PyTorch and some of these other libraries, and they're just shared for free. Right. And you just use them, you can use them commercially. And I just think that's crazy. I mean, and that just keeps happening. Like people just keep building on top of each other. And again, like I said, I feel like where else is that, you know, like sometimes knowledge compounds, but does the work, like I'm sure there are other fields where the effort and everything that everyone's putting in, people keep building up, but like in software, it just seems to be way more than everything else. And then also just software expands, so much faster than anything physical, at least, you know? So it's just like the power that comes from that. And like, that's why like, I like doing YouTube, because, and like, I've been offered some teaching positions, and then people suggest all the time, like you should be a professor somewhere. But if I did that, I would be teaching, you know, I don't know, like 200 people a year or something. Right. Whereas like on YouTube, man, you can reach millions of people, you know? It's like, it's just like, it's so wild, you know, like how this like time that we live in, you know, whereas like I was a portion of my life, I was alive when YouTube didn't even exist, or like even Google search, you know. And I always like wonder, like, what would I be doing like if that wasn't in my life, you know? It's crazy.
Yeah, no, that's a good point to bring up too, is that I've seen that same sort of concept, or I guess mindset maybe, kind of wiggling its way into other industries too. Like just in a general sense, content creation, like video editing, Resolve is free. All of the tutorials and stuff, all the different like texture packs or effects things and plugins and all this stuff. We're definitely living in this time of where the distribution of information, the ease, the barriers to entry to anything is so much easier now than it ever has been, and it's so cool. I get super jazzed.
Oh yeah, you give me chills just thinking about it. Yeah, right? You're right on the content creation side, and then even like just YouTubers in general. That seems to be, and maybe it's just because I've been like slowly like trying, like over the years, like looking into like these are like videos that I look for, but like it seems like there are now like creators for creators. So, you know, they're like giving advice and helping people out and all that. Whereas like, yeah, I feel like when I started, that really didn't exist. I don't think there was a single channel out there that was like telling people like how to actually do this thing. Whereas like now there's so much great advice, and even like the greatest YouTubers are also giving that advice, you know, and I've learned from probably all of the big names, and like some of the stuff just gets like people just like trends happen. So I was watching one of your other podcasts, and they were talking about how you don't want to build. I don't want to get the name wrong. I think it was Sarah, but I might be mistaken.
Sarah Dietschy? Okay.
Yeah. And she was saying how you'll first come up with your title and thumbnail and then make the video instead of make the video and then figure out what the heck you want. And like when I first started, I just titled the videos what they were, and I didn't make a thumbnail. I just like YouTube just picks one and like a frame from the video. And that honestly was perfectly fine for like a really, really long time. That worked. And it was probably partly because of the type of content. Like people would click on my first video, and then usually they're in like playlists. So then they just natively will go to the next video, So like the thumbnail almost made no impact. And that worked really well for like basics tutorials. So like doing the Python 3 basics or like Flask web development stuff or like anything like that works. I don't think a thumbnail really matters. But like if you're making, but like for like project based tutorials, I found that like the thumbnail can like double your views or more. I mean, it'll make or break a video. So, yeah, it's crazy like how important, depending on the type of video, how important those things can become. And like that mindset of, you got kind of have to, and I don't know who came up with it first. First person I saw it from was a Mr. Beast, but I'm sure other people came up with this first. But that like way of thinking of like, okay, first before you start producing anything, think of like the title and what will that thumbnail even be, And I violate that all the time. I make thumbnails like last second usually, but I try to at least think of like, what would the title of this video be? And then helps you to kind of like stay on point. And then also like my videos over time, like when I started YouTube, people really wanted like a 7-minute video or 5 or something, but 10 minutes was like absurd. People would complain if it was 10 minutes. But like now if I do like a less than 10-minute video, people are angry. It's crazy how that's changed.
Yeah, that does seem to be the sweet spot. So okay, to kind of dive into what you're expert of, I think the best place to start is the misconception of AI as a term on its own, but then also how it gets conflated with machine learning and scientific computing, I think, kind of in general. So I suppose I kind of leave it to you to kind of explain the difference and why maybe it's just kind of expand on that, like why maybe we shouldn't be using AI as much as we do. The word or the term, I suppose. Yeah.
Yeah, I guess probably now the problem with just AI, like AI just straight means artificial intelligence. So anything that is artificially intelligent, that's AI. And there's like this, I don't know what kind of chart to call it, but it's like a circle, and then there's circles inside to show you like what's contained in what, right? You've got like AI, and then you've got like at a smaller inside of AI, you've got machine learning, and then inside of that, you've got deep learning. Hopefully I didn't say that wrong. But yeah, so like deep learning is like a type, and machine learning is a type, or deep learning is a type of machine learning, and machine learning is a type of AI. But like AI can also be just a bunch of if statements. It doesn't have to be anything complicated. But yeah, AI is now like such a big buzzword, but so is deep learning. I mean, that's back, like I used to do like contracting and consulting work, and I found that people just really wanted to pay for something to use deep learning so that on marketing material, they could say, we use deep learning.
Yeah.
And like that was so obviously the goal. It's like, just, we don't really care if it even works. Just, we want to do deep learning.
Yeah.
Yeah. It's just buzzword. Yeah.
Yeah. The marketing. Cause like, I think obviously the kind of perception is, everybody thinks like Skynet, right? Or iRobot kind of stuff. The Asimov stories always kind of come up for me, and we're not there yet, right? Like, it's kind of a long way off. Like I've always
that's what you think.
Well, it's like it seems the times that I've kind of looked a little closer at some of these different applications, it seems that it's really amazing stuff, but it tends to be really good at like one thing.
Yeah.
Right. Like the software that you're using to identify a cat is not going to drive your car. Right. So it's not really intelligent. It's just really good at that one thing. And I don't know. I feel like it gets a little mixed up. And I hesitate to ask, but it feels like the natural progression is that really where it's headed? Like, is we have chatbots that are easily pass the Turing test, right? That it can fool another human being into thinking that they're chatting with a human, but like, are we really at the point, or even on a near horizon, close to intelligence, like fuzzy sort of learning, that kind of thing?
Yeah, it's funny that you mentioned like chatbots tricking people or whatever. I can't even remember what it was. I think it was a GPT. I think it was like Dialo GPT. I think it was from Microsoft. And I just slapped that onto a Twitter account.
Mm-hmm.
And I told people what it was. I told people this is a Dialo GPT chatbot, but people could DM it. And so I just left DMs open because like some people just didn't want to publicly tweet, I guess.
Sure.
But and people would DM that bot, and then even going into it, knowing I said this is a bot. I believe the profile even said it. People would go into the DMs, and then they would talk back and forth, and they'd be like, "Oh, I thought, aren't you a bot?" And then it would say, "No, I'm not a bot." And they're like, "Oh, I thought you were a bot." And then they'll continue the conversation. And it's like the wildest thing that even being told, like, "Hey, this is a bot." They go in, and then the bot still manages to convince them it's not a bot. It's wild. I think what basically what you've described is like what is called like narrow AI. Like the AI that we have today is usually trained to do like one very specific thing, and like that's all it does. And you can then like take those models and like fine tune them on other tasks. So like nowadays we have these things like GPT style models that are like GPT-3 from OpenAI and stuff. These like massive sized transformers, and they're typically used on like language tasks. At least that's at least how they rose to like prominence. But even now, you can use those, and like again, you can fine tune those to work on image data and do like image captioning or captions to images. I mean, it is pretty wild that like I think like getting to your question of like like where are we? I think we are like narrow AI, but I think I think people misunderstand like how wide narrow can be. I guess
I mean, yeah.
And so like with GPT and like some of these things that transformers can do, I find that like even people who know about deep learning but maybe haven't kept up with what these like GPT style models are doing are shocked at like how good those models are. So and I'm still amazed. And so like for example, GitHub Copilot is like it's like a plugin, I guess, that you can bring into your code editor, and it will like predict and help you to code. And it essentially it'll like code for you almost. Like if you just add in like comments and say like what you're intending to do, and it will just generate that code. And like it's surprisingly good. Like there's some stuff that I'll try to do. I wish I could think of like a really good example off the top of my head, but like there are some stuff where it still seems like, wow, that was impressive. Like I can't believe that it did that.
Yeah. And
it's shocking how good it can be at what you would describe as a very narrow task of just being able to generate code. But coding is a really tough problem. And like what we were talking about before we even started was like self-driving cars, I guess you could describe that as like a narrow AI problem, but it's really pretty general. Like it gets very general. And there's so many edge cases that to really solve it, man, you're going to need really great AI that is, I think we're always like moving the goalposts, like for the longest time it was a Turing test, but we like just obliterated the Turing test. And like someone like me, and again, like I was saying before, where it's like everything is free and you can just download it. There's all these like pre-trained models. That's all I did. I just downloaded a pre-trained model. I didn't do anything. I just coded in the little chatbot part of it to Twitter, and that was it. And boom, the Turing test is beat. And so it's like, and now it's like, that's not impressive. It was kind of like chess, for example, like AI winning at chess. Like that was the holy grail, right? I thought. And then as soon as it happens, okay, well now we'll move the bar. Oh, what's another game? We'll do Go. And then Go is beaten. And it's like, well, we're out of games. We don't have any more games to try.
StarCraft.
Yeah, right. But it's over. No way they'll do StarCraft. Yeah. So it's so the goalposts keep moving. And then I think like what's possible, like we're kind of seeing that lately, like with like deepfakes, for example. Like I think
that's a good one.
For the longest time, like I would tell people like that don't know about programming, I would explain deepfakes, and I'd be like, yeah, I know, I'm sure you've seen some of like the apps and stuff where it looks very fake, but
Mhm.
we are already at the point where for sure, like I don't know how good the quality of video is coming over, but at least like the little window that I see, that is totally deep fake. Like you could easily deep fake me to be saying anything I want or anything you want right now. You know, and it like there are some techniques that people can use to like validate a video and determine is this a deep fake. But by the time it's like gone out and it's gone all over social media and spread and people's opinions have formed, and the waters have been muddied already, it doesn't matter. It's already here that it's enough to just like sow doubt or whatever you're trying to do with your deep fake. And I think, like I said, I think very recently we're starting to see some of these come out like really by bad actors, and it's I think it's the first time that people are really seeing this, and I think people are still not aware of how bad it can get because you can produce deep fakes. It can take a lot of processing power, but I think you can produce a deep fake quicker than people could get together and disprove the deep fake. Like it's like a social denial of service attack where you could just like keep sending all these deep fakes out, and it would just cripple people because you would never know like what is the real information here. And so like and seeing is believing. So video is just it's so powerful for most people. And like audio too, we can fake audio pretty well. Audio's tough. Audio is harder than video apparently. But even that is getting pretty good. And again, these are just things that are like out in the wild in public right now. So I'm sure like nation states have better technology than like what I can find on Google or GitHub.
Sure. Yeah. I've always been a big part of especially things like deepfakes or I suppose just a lot of a big part of this that I've never really been able to wrap my head around is how does the code, like I understand training a model on like good data. You have 1 million images of cats that you know are all cats because humans have verified that, or you have good data coming in. But at what point does that translate then to like a new picture? It looks at it and then it comes back and says like, I'm 85% sure that that's a cat. How does it get to that point? Because like the only way my brain wraps around it is a bunch of like checks, I guess, like if almost if then, like if these patterns are there, then okay, I add a little bit more to my like confidence level. But if that seems really reductionist.
Yeah, it's tough. I think yeah, I mean to some extent like neural networks are black box in the way that like in many ways that they work. Like at least my brain can't think in the number of dimensions that you could theoretically have like a neural network be thinking in, or maybe my brain does work that way, but like my logic in my brain doesn't work that way. Like sure. I can't imagine it. I can't imagine those scenarios. Whereas, cause like it's usually, it comes down to like with images, like very, very small, like patterns and shapes that then get, as you get bigger out in different layers, they might do bigger shapes or different types of shapes or whatever. But you like it does stuff like that, and we understand that. But in terms of like, I don't know about deep fakes. If somebody knows truly every step of the way, how did it get to that exact point? I'm not sure. I'm not sure people know that. There's probably like I know that there's been a lot of research into deep fakes because of the problem they present. And so I know a while back, I think it was Facebook and maybe somebody else did like a competition, and you could like download samples of deepfakes and then like real videos and like try to determine, like write algorithms to determine if it's a deepfake or not. But again, I'm pretty sure people are using deep learning to solve that problem of detecting a deepfake. I don't know. Like sometimes you can look at videos and determine it's a deepfake, but if you've like there's been like every time I'll see like a video on like Twitter or sometimes even like, you know, major news articles and stuff like that, the video quality is like 480p or something.
Yeah.
This is unacceptable because it already is like high. It's like not just 480p, it's like super compressed as well. And so when somebody like moves their head like side to side, you get all these like artifacts. And that would also be how you would like detect like, oh, something's up here. This might be a deep fake. And so I think like we gotta stop doing that. We gotta stop accepting these these like super compressed and low res videos. You know,
Mhm.
so like in that way, like if something is low res enough, or like sometimes you can just tell that someone's head didn't move right, or this it's kind of like Photoshop, right? The skin of the face doesn't match the neck, or something like that. And for a while, like hair was really tough to
Sure.
do. There was like other stuff, but it's so, or glasses were hard, but now not a problem. So it is very like it's constantly evolving. But yeah, as far as like how they actually do that, like with cats versus dogs, there are just patterns that are that exist with cats that just, and like it's not just like a single, it's not like just that single element, it's like the combination of all those elements. Like if those activate in the network, then it's just can become like a probability, like this is 85% a cat, because
Right.
we've seen all of these patterns that we've seen on the past, like, you know, 400 or 400,000 images or something like that.
Yeah.
So that's my intuition of how that's working. And like we at least like we can look into a neural network and we can track like the actual numerical values as they pass through that neural network. But I don't know that, like, this has always been problematic. Like when we use facial detection in policing, for example,
Sure.
we can't, we still, to my knowledge, we can't like prove like that this algorithm does a certain thing, or, and many times we can't explain how or why it did that thing.
Yeah.
So it's definitely still a problem. But I think if we asked people, like, how did you come to this conclusion? Like, truly, like, give me all the reasons that you came to this conclusion. I think most people can't. Like, there's so many factors that go in, and you probably don't even know, like, all the biases that you hold. And so, yeah, it's tough. I don't. It's going to be a tough field to navigate as we go forward, because models are only getting bigger and smarter. So.
Right. Yeah, that's the thing. I remember one time talking with Dr. Don Kinghorn. He's in the chat. He said hello in the YouTube chat there. Oh, dang it! I kind of lost my thought. Dang nabbit. We were talking about the kind of the dangers of it, the face recognition.
Things are getting like bigger and bigger.
Oh yeah, we've over the decades we've collected so much data, like what all kinds of different data, medical data, and social interaction stuff, all this data. But it's only just recently, like in the last maybe 10 or 12 years or so, that we've had the processing power to actually like do anything with it. And we're seeing this huge explosion of we're doing all kinds of cool stuff with it. We're making robots that dance and cars that drive themselves and chatbots and all this stuff. And it's kind of freaky. We're at that point where it's like we're doing all this stuff without really stopping to think if we should, right? Like that bit from Jurassic Park. And because, like you said, a lot of this stuff is really scary and potentially very dangerous. And it's hard to weigh the like risk to benefit, I think.
Yeah, I think getting to like the data thing, I think I've had this conversation with so many people, but if you're ever bored one day, you should download your Google Takeout data. It's like, I don't know why it's called Takeout, but it's just Google Takeout. If you Google Takeout, you can download all the data that Google has on you. And first, you probably don't even recognize all the things that they have. Like every time you use the assistant, for example, every audio recording is there. You can listen to it right now, and obviously so can they. And so, but that's just like one of like, I don't know, 100 different categories that they have data. They have data like when you did a search on your phone, where were you? Like, what are your coordinates when you did that? And like, so it's not just like, oh, they just have your search history. No, they have like your life. They have truly everything. And if you're using Chrome browser, they've got every website you ever visited. So it's not just like, and all the keystrokes that you typed, they have like, it's just, I'm at a loss for like naming all the things, because there's so much stuff. And if you just look at it, you can then make the decision if you want to continue to use all of the Google products or maybe start to look for other sources. I still use the heck out of Google. Obviously I'm on YouTube. I use Gmail, all that stuff. Like their products are really good, but yikes, there's so much data.
Yeah.
And so if you just see that, like, I just have to cut back a little bit. But yeah, like Google, for example, could easily fake like my voice and my video, and like they could totally or if someone was able to access that information in any way. So yeah, I forget how I got on that train, but yeah, just in terms of how much data is collected, I think people are unaware of how much. And like some people are aware and they still don't care, and that's fine. Like if you like what you get in exchange from Google, but just make sure you're aware of like how much how much is there, because it's a lot. And like you forget, like, oh yeah, I use that product or service, or oh yeah, I use that thing. And like Google has such a huge ecosystem, and they make awesome products. And I even use some of Google's like more physical products, and because they're the best. I mean, they're at most of what they do, you know. Like they have failed at some stuff, but yeah, so anyway, yeah, there's just the amount of data that is collected. Yeah, like we've probably like not even come. It's so weird because like every year we get way more and more advanced AI. And like I feel like we had like deep learning came out before we even recognized what was the true potential of like more traditional stuff like k-nearest neighbors or support vector machines and stuff like that. Like we didn't even like realize that full potential, and then deep learning comes, and so we're using deep learning. But the moment like if truly like a quantum computer comes into existence with enough qubits, now we don't have to do stochastic gradient descent anymore. And now we're just like, boom, instantly solving every problem that we throw at it, provided we have enough data. But now we don't have to do what is effectively like, I don't know, a brute force method of training these neural networks. So if that ever happens, oh my gosh, like now it's crazy. Yeah. And like, who knows, like with like, even with GPUs, even with NVIDIA just doing their thing all alone and nobody's really competing with them, they're still, you know, producing crazy powerful GPUs. And then now you got AMD and Intel like nipping at the heels of NVIDIA now. And if those two can start producing like true deep learning cards, that would be like the greatest thing, because now we would have just incredibly powerful GPUs. But I think with regards to like, should we fear, you know, AI? I don't think we fear AI. I think you should fear the Googles and the Facebooks and like whoever can, like, I don't really think AI, like if you really had like an AI, I think it's the movie Her. Like, I'm trying to remember if it's that movie or a different one, but
it's like he falls in love with his phone, right?
Yeah. And then
the Siri equivalent there.
And then it has no interest in him because it's a super intelligent being. So it doesn't really care what the humans are doing. It just goes off and hangs out with the other super intelligences. It's like, I don't really, as long as like hordes of ants aren't violating my home, I really don't care what they're up to. You know, I'm not really worried about their affairs. And so my guess is like truly intelligent AI. The threat is like if AI recognized us as like kind of the parasite that we can often be, that would be bad. But other than that, you know, I think mostly like a super intelligent AI wouldn't care about us. So then you've got like the people that control the narrow AI. I find that to be far more threatening than like, oh, boy, how intelligent will you know, artificial intelligence get? I'm not worried about that.
Yeah, no, I agree. That bumped into something I wanted to talk about too. I feel like we're going to have you on another episode. We're already halfway through, and I barely touched on like 3 things that I wanted to talk about. Algorithms. There's always the algorithm, like whether it's YouTube suggesting or not suggesting stuff, or Instagram, you know, For You page, or TikTok's, you know, offering up content that they think. For me, like TikTok's incredible at their content, like offering algorithm, right there. And that's got to touch on some AI a little bit, right? Like
100%.
That's within that big circle there. Yeah. And can you talk about on like how that kind of works a little bit, so people have a little better understanding of what because quite frankly, how they're being manipulated.
Yeah, I think, yeah. So yeah, I guess that could be like a good reason to I guess fear AI. Like I think it's called like The Social Dilemma, maybe on Netflix. Got into it a little bit, where like well, I know the most about the YouTube algorithm, but like the TikTok algorithm is also, I think TikTok as like a platform is just really good because it's that short form kind of content. And it as an algorithm can learn very quickly what you're interested in, because every video is like 30 to 60 seconds. So that algorithm can be trained really quickly. Whereas like YouTube, you're watching 10-minute videos or something like that. And then it takes a long time to determine like, like when does someone bounce, for example. So like on YouTube, if someone leaves YouTube while they were watching your video, it's like the worst thing ever. And like YouTube, it like hates that,
Yeah.
So like with the algorithm, like with Social Dilemma, for example, like what they touched on was, just kind of like outrage as one of the unintended consequences of, like with YouTube, for example, we're all competing for watch time, right? Sure. And I'm competing not only with other YouTubers, but with Netflix and Amazon Prime and like all these other, like we're all compete, because you could theoretically watch 2 pieces of content, but nobody really does that. Right. So it is like it's a zero-sum game. If I take a view from somebody, like that's mine, and YouTube knows this. So if YouTube takes a view from somebody else, and it could be anything, like they're competing with sleep. So sure. Netflix would rather keep you watching up late at night and getting into the habit of sleeping for 6 hours rather than 8 hours, because that's better for Netflix. So like all those things can be kind of detrimental in the macro. But at the end of the day, they still do a pretty good job. Like I remember the early days of like Google search and even YouTube, it was not good. I mean, the content was not good that was offered to you. There was no way you could sit down and obviously it was much smaller, like the ecosystem was smaller, but I don't think you could sit down and really just get sucked, go down the quote unquote YouTube rabbit hole, like I don't think you could do that like before they had real good algorithms, but now they're pretty good. And sometimes that can lead to bad things. But I think probably going forward, yeah, you would want to like focus on, like I wish they were a little more open about, how they're doing things and how they're changing things. Like at least for me, I get the feeling that YouTube is like 2% open. Like they say things and it's so demonstrably like false. Like it's just like, it kind of irks. And so I wish there was maybe a little bit more like upfront and kind of honesty around like how, like, you don't have to tell me how to game the algorithm, sure. But it would be nice. I think we know at the time, like now we know the main thing is watch time. That's sure. What YouTube cares the most about. And really like, this is not a challenging algorithm to do. So in general, like my best guess, like what YouTube does is they at least, well, we know they're doing this because there was like Kaggle challenges and they were hiring people to do this. Like they are annotating videos. So there's AI, it's all deep learning. So same thing with like TikTok. There's no, okay. I'm sure they use some like hard coded metrics at TikTok and YouTube and stuff, but I would say probably 95% of that, it's got to be deep learning. So, my impression is YouTube is probably annotating the video as it's playing. So they've got an algorithm that's determining, and that's why people will like blur, like if it's a word that is no good, like if YouTube might demonetize you if you spoke the word, and if you show it on the screen, you will still get demonetized because it will recognize that word and it knows this word existed. So you'll see people will blur out word that they don't want the algorithm to know was like in the content or something. Sure. So it's definitely annotating. So the algorithm has some idea of like what this video is about. Most at least English, the captioning is like all automated captioning. Mm-hmm. Again, that's all for sure deep learning. So it knows like the subject matter, and then it's taking that and it kind of categorizes and classifies that, and then it has profiles on you. And again, YouTube has, like I said before, they've got everything on you. So they're just matching it to you and people who are like you in certain ways and stuff. And like, that's how it's, I don't work at YouTube. I don't know how that algorithm exactly works, but that would be my best guess. Like they know what the content of the video is and they know everything about you and all the videos that you've liked. And then they just compare that to other people who are just like you, because they've got, billions of people on their platform. So yeah, I think that's how it works. But
okay. Yeah, no, and well, kind of that insight then kind of gives an opportunity for as a consumer to sort of game the system a bit too. Like if it knows so much about you and then your search terms and things, like you can then, I suppose, more easily find content that you're actually interested in. Because sometimes it's still pretty bad. Like why did Pandora suggested me Frank Sinatra in my Paramore radio, like that doesn't make any sense,
right?
That kind of thing. So
definitely like with TikTok, for example, like TikTok will peg you like super fast. So like TikTok determined I was a I don't know, like a male in his 30s. And so immediately they try to send you things like cute girls, right? And if you spend a moment on those, like you got to swipe instantly. Otherwise, that's going to be your whole TikTok all of a sudden, because a bunch of people your age, that's all they do on TikTok. And so like sometimes it can be annoying, but yeah, knowing that that's what they're doing, right? If that's not what you want to see, or maybe you want, like, I like to watch like dogs on TikTok. So like I purposely, like if it's a dog thing, I'll hang on that one. I might watch it twice, and then I'll swipe. I'm just like, come on, algorithm, this is what I want. And then like every now and then it tries to show me some other thing. And so like I keep like you have to train the algorithm sometimes.
Sure.
So yeah.
Makes sense. Man, there's so many different things I wanted to ask about. Like why does Python seem to be the programming language for scientific computing?
Yeah, that's tough. I actually don't know why, like in the early days, why did Google choose? Because really, there was Theano. That's what I started doing deep learning on. That was like a Python package. I don't know who made Theano, but really someone else beat Google to working in Python. And I don't know for deep learning and scientific computing. So then there was also like Pandas is like a kind of scientific computing. It works really well with like CSVs and stuff like that kind of structured data. Pandas is like, I don't think there's an equivalent in some other language. Someone might be angry in the chat about that, but I think the reason is it's just so quick and easy to work with it. And people often make the claim like Python is slow. Like, why wouldn't people use C++, for example, or something like that? But all of the things like TensorFlow is not pure Python. Like it's got, like, if some other language is faster, that language will be used. And then essentially just a Python API wraps around that. So you can still interact with it in Python. And when it runs, it's not running pure Python. It's not only Python that runs. So it's still, it's like really rapid to develop. And then it's really, you pay almost no penalty. Like there's still things that you can't use Python for. Like you can't use Python for like low level, like you can kind of wrap it for robotics, but again, like it has to, there are certain things it doesn't do well. And like you mentioned game development earlier, I would say probably the weakest link in Python is game development. Like there are things that you can do game development in with Python, but I don't think there's any like major game studio that is using Python for anything.
Sure. Yeah, that's because I know that in some other talks about it or in poking around, there have been mention of other languages, but it does seem to be the dominant force. Like if you're going to get into this, you should learn Python.
Well, there was like MATLAB, and I'm sure MATLAB is like still really popular. And there's like other languages that people like use, and people are still trying to push for like Julia. It's very Python-like kind of programming language. And that's the problem, is it's like, why would I use Julia over Python? Again, people are gonna be angry about that statement, but it's true. Why would I do that? Like the ecosystem, I think it's just kind of like, it's like that self-fulfilling prophecy with Python. Like for me, what brought me into Python is the syntax is almost legible. Like I think you could come in and read a lot of at least like if it's like a script, object-oriented programming kind of bounces around sometimes, but like you can probably just like, even if you didn't know Python, you could probably like understand like what is happening here. So it's just like real friendly to like newcomers, but then it can get like really complicated really fast. You can do basically everything in Python. So I think people just started using it, and there's all these like really powerful packages like NumPy and Pandas and all that for like scientific computing. So I think just so much of the scientific computing community was like already there. And then I guess that's why, but I'm not really, like I said, I don't know if anybody, I don't know. I'm sure somebody beat Theano to like be like a deep learning kind of package to Python. I wish I could remember. There was one more, but I can't remember what it was called. And I could even be wrong. Like development of TensorFlow could have started before Theano. Like, I don't really know. I just know Theano is the first one I used, but yeah, I don't know. I'm not sure why they picked Python, but my guess is it has such a huge ecosystem. I mean, so many people know Python.
Yeah, that makes sense. So you've mentioned deep learning a few times. How is that separate? Like, what is deep learning in the context of all of this compared to an alternative? I guess I don't know what
sure, like deep learning is neural networks. I mean, that's okay. So like if someone's using neural networks, as long like in theory you have to have I think it's 2 or more hidden layers, like it to be like deep learning, but just essentially neural networks. If you're using neural networks, you're doing deep learning, and that's it. Like like I said, there might be some edge case that I'm missing, but I don't think there's anything else that constitutes deep learning.
Okay, and so again, I feel bad for doing all this real basic stuff. Neural networks, then What is that?
Matrix
In the
multiplication.
Okay.
Just matrices being multiplied by matrices, and then to the like, so like neural networks, basically you take some data, you pass that data through and all these like matrix multiplications, and generally you've got like a full, like the most basic would be like a fully connected neural network where like each little node is like connected to all the other nodes, and they're just each node then would be multiplied by a weight, a bias will be added, that's your new value. That passes through some sort of function that will be, it's called an activation function. And then you just basically go all the way through the network doing that. And usually the activation function is really basic. So the most popular one, I think still to this day, is the rectified linear. Sounds really complex, but as long as the number is over 0, it's whatever that number was. So again, like every little element of neural networks is actually unbelievably basic, simple. Anybody can understand like how they work. The hardest part is like the back propagation part, where you're trying to use it, like you need like some sort of algorithm to tweak those weights and those biases, because you can't tweak your input, right? That's like your actual input data that you're trying to train on. So the hard part is like, how do we tweak those weights and biases? And the best way that we know to do that is like gradient descent. And that's why, if again, I'm not the most intelligent here, but my understanding of quantum computing is that would solve gradient descent, right? And that's why it would be so exciting. Like if you had enough qubits, right? Like we're nowhere close enough qubits to like IBM has some that you can like play with, like their quantum computers, but you would need a lot more, much bigger. But maybe over the course of the next like 10, 20 years, like we might be there. And yeah, that would be like super exciting. But yeah, even the gradient descent, that's using calculus. But even that calculus, like I think to write the proofs, I might even have a hard time writing all the proofs. But really, it's rules. Like it's rules of like, what do you do in this situation when you have these types of things, like an exponent or two things are multiplied or they're adding. The rule is always the same. So again, it's almost like hard. It's really not that hard. Like you just have to like memorize these like very simple rules, and because you don't have to prove it, you just know that this is how we do gradient descent. So yeah, even that, like I said, I think to do the math proof might be hard, but yeah. So hopefully that gives you a decent explanation of how they work. But
yeah, well, it just leads down to more questions, more because I get the idea of, you know, it's a lot of a lot of simple pieces being all kind of added together to make something really, really complex. And it just is never, this is one of those things that I feel like I could never know enough, because there's always more questions to ask. There's always more things to learn about this, because it can be applied to everything, anything, all sorts of cool, depending on how you want, I guess, just depending on where you want to end up. There's a application there. It's super cool. And it's mind-boggling. And it's really, wow, oh man. I'm curious. I'm just to kind of get back to kind of some of the questions. What's been your favorite project, either that you've worked on or that you've come across in the industry?
Oof. Man, that's a tough question. I think probably the coolest one, at least recently, I worked on this with Daniel Kukewa, who's also, he co-authored the Neural Networks from Scratch book that we wrote and all that. He's been working with me now for, God, I can't even remember now. Like I said, I feel like I've been programming for 6 years, and I feel like Daniel just started working with me. Probably, I'll just say 3 years. I don't know the exact number, but a while. And we did a GAN theft auto. So it was a generative adversarial network. And basically what this did was, and this was like built on top of, I'm blanking on the name. It was a like a research project from NVIDIA. I can't think of the name of it, but anyways, it was using GANs and Game GAN. It was called Game GAN, and then we called it GAN Theft Auto from there. And so we just adapted it to using Grand Theft Auto. So you would play, and then the neural network we would like train the neural network, like here are inputs, and then like when this input is pressed, essentially here's how the game world changes. So we were just driving a car down like a stretch of highway essentially, and what we did was we trained it in Grand Theft Auto, but then at the end of the day, you're essentially removing the game engine, right? So now the neural network is the game engine. So you press key presses, those key presses go to the neural network, and the neural network generates all of the imagery for you. And this would include, and this does include, like shadows on the car. Like you could see like the sun going over like the window and reflecting off of the car. And you can see like when you change directions, like the suspension changes on the car and stuff. So it's like, it's not perfect matching physics, but it was very close. And there was even like little inconsistencies that people would point out on the video. They were like, it looks like the sun is a little weird as it goes, like it's going the wrong way. Like it really did look wrong on the video. But then we went back and looked at like the original video, and that's exactly what it was doing. Like the sun was actually reflecting in that way. And then I can't remember the actual like reasoning for like how it was doing that, but it was almost like an optical illusion. Like when you're looking at it, it was kind of confusing, but it even like did that. Like it just did everything like perfect. Like there was nothing it didn't figure out like to start how to map rather, at least when it was alone. And then we tried to add like more cars, you know, and there was at least points where, you know, you could come up along the car, along like the side of the car and like try to turn into it. And normally, like if there wasn't a car there, you could totally turn and continue doing whatever you wanted on that road. But when the car was there, we could not turn into it. And then you could almost see where you could start to like pit maneuver the car or something. But then like the network would just be like, nope. And it would just like disappear the car. So,
oh, geez.
Yeah, it was very like dreamlike. Like most people like would say like, oh, this is like a neural network dreaming is kind of how people described it. But yeah, if you just go to YouTube and you type like GAN space theft auto, you can see the video. There's like, so you can see like how that works. But like to me, that was really cool because it was like the first time I was like thinking, wow, you know, like the future of like applications and stuff, you know, like we're still like super far from that, but like your computer could be neural network based. And then, you know, people would comment on that and be like, I'd rather my computer to be deterministic. And it's like, well, your computer still like has lots of software and flaws and all kinds of errors come up. Like it's probably more likely, especially now seeing what some of these very large networks are already doing, it might do a better job than people who made all your software. Because even just to run the most basic program, there's like so many things are stacked up. And I mean, I've never had an error-free computer, so I suspect we might have better results with neural networks. But we're obviously, again, we're so far from that. But that was the first time I was like, wow, this is a completely generated neural network environment. You're playing a neural networks game, and so it's making all the rules, and like that's crazy. Like it's so trippy.
Yeah. Well, yeah, so I pulled up the video and I put the link in the chat there, and yeah, I see what they mean about it being kind of dreamy. It's like everything's a little smudgy kind of looking, and that's interesting.
Yeah, and that's definitely like, yeah, that's all like super early days. Like that kind of technology could go like so many places or none, you know, who knows?
Sure.
But yeah, I think that was like one of the cooler things that like, cause like so often you like work with neural networks, but then you don't really get to like interact with the neural network. Right. And so like for example, one of the things that I've been playing around with like NVIDIA's, it's called like Omniverse, and they've got like all these like tools inside of Omniverse where you can, it's essentially, I don't know how to describe it. Like it's like a 3D environment thing where you can create stuff or you can do like robotics and stuff like that. And one of the things that I don't know if it's already in yet, I know it's supposed to be coming, is VR. And since I already trained like some reinforcement learning agents, like a little robot dog to like walk like in the simulator. But like with VR, now you could interact with so you could, I don't know, train something to play table tennis or something like that. Yeah. And you could play with it. Like you could actually truly play with your agent. I just think that would be really cool, like in a VR space. It'd be different. Like you can already train like something to play Pong or something on your computer and play with it. But I don't know, like the concept of like AI in VR that you get to interact with. I don't know. I think there's something there that is like really cool.
Yeah. Well, I mean, it kind of ties to that chatbot almost idea of like, how could you be sure you're not playing against somebody else?
Right. Right. Yeah.
I mean,
and even like the chatbot, like even, you know, I know it's a chatbot, but it's still really fun to talk to, you know, It's fun to just like, to truly like see what it, like, it's not real thinking, but it's still like, I don't know. It's cool to interact with neural networks in some way other than just like passing in some data and like having it label or classify something. But yeah.
Yeah, no, I agree. I mean, don't get me wrong. That is incredible. Like the identification stuff for classifications and things like that is tremendous. And the work that must have gone into that is massive as well. not to downplay any of that, but yeah, I agree. Interactivity, I think, is the cooler application.
Well, it's just stuff you never thought about. Like I never considered that you could have like a machine learning algorithm of some kind. It didn't have to be deep learning, but then it could create something like a game environment, and you could play within that environment and actually get the results you were expecting. You know, like on the Grand Theft Auto, you could run into the edge like a barrier,
Mhm.
you know, and it would correct the car. It would not let you go. Like if you hit it straight on, you would just essentially stop. But if you hit it at like an angle, it would just like correct the car basically. And like the things that you expect out of it like happened. And again, it was like obviously like really basic. It was like just that little stretch. Right? You couldn't leave. It was not the whole, you know, Grand Theft Auto world. But yeah, I just think that was like the coolest like glimpse into like technology that we've not even like, I had not even considered like, wow, this could be a lot of, like you could do a lot of applications this way. Like you could replace everything with this. Not that you should or whatever, but it's just like, wow, I never even considered that. Yeah, that it could be, you could have an AI operating system. Like that could be in the future, you know?
Wow.
And so like it's like, and again, like it's outrageous to say that right now. And, but it's like, that was like the first time I was like, huh, yeah, I never really considered that, but yeah, that might be, you know, and
That'll
then,
be interesting.
and then even
Yeah.
like I brought up before, like Copilot, you know, I think I'm so in love with GitHub's Copilot. Like, it's just the greatest thing ever. And if you ask me, like it was always the dream to get like algorithms to generate code for you, and like this has been going on for truly decades.
Mhm.
I forget who was like the original like pioneer. It might be Microsoft even, that was like the first people to like really try to put it. But I'm talking like the 80s or 90s or something. Like they were trying for so long.
Yeah, I remember when so I was doing programming when C# and
Mhm.
the .NET framework and all of that was just starting to be commercially available. And IntelliSense is what they called
Mhm.
it in their IDE, where it would try to guess what you were trying to do and offer up
Mhm.
suggestions to finish out the line or variable names and things like that. And it sounds like this is sort of a progression on that, but backed by like all the code that's available in GitHub. It's
Yeah,
like that's
yeah,
amazing.
and it's actually intelligent. Like, and again, like I think for a while people would see like GPT-3 and think, well, it can produce like something that looks like text, but is it actually intelligence? Like, does it actually
Mhm.
like have a knowledge base, or is it just like a lot of people
Yeah.
will say it's just regurgitating, but it's I can't quite put my finger on like exactly what it is, but it's 100% like I can definitely say it is not just regurgitating. Like some stuff is very similar to maybe what it's seen before,
Mhm.
but it definitely is like reading your previous code. Yes, it knows all of like history of GitHub essentially, but the results are just like there's some really bad ones. Like you could definitely like ridicule GitHub Copilot all day, but you don't, yeah, you can just ignore it. It's just like autocomplete basically is what
Sure.
IntelliSense is. And so it's like that. Like you don't have to use the suggestion, but I find myself, I would say more often than not, either using that suggestion or even like I've learned new stuff. Like it'll suggest a thing and I'll be like, oh man, I didn't even think about that.
That's
or
huge.
or if there's like a package or like a thing that I'm trying to learn, like I'll just I'll just import the package and then I'll just hit enter because you got to follow PEP 8 because that like it follows like the coding standard of Python. So sometimes you'll hit enter and you'll be like, why isn't it? Well, oh, you got to follow PEP 8. So you hit enter one more time, and it'll suggest like stuff and then like I've used it to just teach me like a new package, you know?
Wow.
And all you have to do is just throw in the comment of like what you want, and then it just like kind of generates that code for you. And yeah, it's like I did not. It's like we were talking about before. Like I think a lot of times people overestimate where we are with AI or they move the goalposts. But then I think a lot of times too, in many fields, people are underestimating where we are like right now. And then also like GitHub Copilot, I don't even know how long that took to train. Probably, I would guess years. So that was so in theory, that's like technology from like years ago. And so so we're already like it's just such a crazy field to be in. Yeah, and
Yeah.
the way things are progressing, hardware, software, all that is incredible.
Yeah. I think you touched on an important point there about the intelligence of it and its context. Like the GPT-3 stuff can produce. I think GPT-3 is actually really spot on. They're depending on how you apply, what they've done there. It's context, right? I use a few tools to try and like write up headlines and stuff for social posts or whatnot. And sometimes I'm like, this is really dumb. Why did you even suggest this? And it's because it lacks the context. Like it's trying its best based on a certain framework of copywriting and things like that. But it doesn't understand that fuzzy part of it of context. That's the best word I can come up with for it. And so it produces weird or just irrelevant results and things. And man, I don't know. It's just it is really, really cool to where we're at. Cause I've seen it done. There was somebody who had like a blog that was for like years, for like 2-3 years. And the person behind it never actually wrote a thing. It was all generated by GPT-3 stuff. And there had been a few comments like over the span of this blog where like, this seems like it'd be AI generated. Like, is this real? And for the most part, people couldn't tell that this was somebody actually writing this stuff up. And again, I think it's that context. It's like, it depends on how you're applying some of these tools. Otherwise you're going to get weird results.
Well, especially like starting, like if you're just trying to generate like a title, like usually you have like I've heard it called all kinds of things, but like prompting, for example. So you give like 3 good, like a description and then a good title, then a description, then a good title, and then a description, and then you let it generate that good title that you were hoping for. And so you definitely need to have like good prompts. And that's why like with programming, it's just like, it's like such a perfect fit because that's exactly what you do. You just make a little comment. That's your prompt of like what you want to do. And you've got all your previous code. In general, at least in Python, things are pretty linear. Again, like with object-oriented programming, it can bounce around. But again, it knows that. Like GitHub Copilot definitely understands object-oriented programming.
Sure.
And the other cool thing, like you mentioned, context. I think GPT-3. This is just off the top of my head, but I think GPT-3's context size is 1024, whereas GitHub Copilot is 4096. So it's like 4 times larger context, which essentially that's in, I want to say like bytes. I don't know. I might be wrong, but I think it's bytes. It's like little bits of information basically, but it translates to about like 600 lines of code. So as you're getting like your predictions, it can read up to 600. So like if you get past that 600 lines, you might start getting like weird things again because it can't do the full context.
Sure.
But then it also does, like I've noticed, I haven't seen it said anywhere, but I'm fairly confident that GitHub Copilot reads your other files or it holds cache or something, because there's like things that it's done to me that I'm like, I'm just throwing my hands because I'm like, no, there's no way that it knew that that's what I wanted. It had to have read the file name or the other files in the directory or something. So it's definitely pulling in other context too, but something about, and obviously your lines could be different lengths, but about 600 lines, I want to say. So that's a huge context. I mean, so yeah, I'm totally shilling for GitHub Copilot right now.
No. Hey, anything to make programming easier, honestly, like that's great.
It's just fast, right? Like it's easier, but then it's fast. It can teach you stuff. I've seen some people don't like it because they feel like maybe it's not helping them to improve as a programmer or something like that. Like you can use it as a crutch if you want. Yeah. But I don't know. I think you still have to be able to, you still got to read that code. You still got to know what you intended. And then when it spits out that code, you still got to kind of analyze it. And like, you can still make tweaks to it and stuff like that. And so, cause it doesn't all, like I said, like it does make mistakes, but it's just one really cool, like cause like so much of like deep learning is just like in the research field. You don't really ever, like for example, Grand Theft Auto, really cool technology, but we have no idea like, okay, well, how do we like make a cool product out of this? Like an actual thing. Right. Whereas like GitHub Copilot, it's kind of like GPT-3 for the longest time. People were like, yeah, that's cool, but what are we really going to do with that? And then now we see it's not GitHub Copilot isn't GPT-3, but it's a transformer model. Sure. And so like what a cool application. And again, it's like stuff that you just, I thought maybe that could happen at some point in the future, but I just thought we were so far away from it, and then it just happened. Yeah, and it's so good, like right away. It's crazy. Like I was just surprised at how good it was.
Yeah, that's super cool, man. I hate to say this, we're a little bit over our hour, and so we'll have to wrap it up. But we'll have to get you on again because there's so much cool stuff. I mean, like GTC is coming here. I think it's next week, overlapping with GDC, and I imagine NVIDIA's at the forefront of all of this. I feel like they take all their gamer money and they have been just dumping it into science stuff for the longest time.
Do you think? Do you actually? You might have insights on this then. Does NVIDIA actually make more money on gaming? I would assume they make currently more money on like server grade deep learning stuff.
Honestly, it'd be hard to say because just off the cuff, the equipment that goes into that heavier stuff is a lot more expensive. We're talking $4,000 for like the lowest end Quadro card kind of thing. Well, that's whatever.
And the markups on those are huge. Yeah. But then also like every person that like companies aren't buying one Quadro card. They're buying 100 Quadro cards. It's like the scale, like AWS, like for example, all their cards are NVIDIA cards, right? Like, so I've just always assumed that the deep learning market at some point in the past already surpassed gaming, but I'd love to know like what the answer is there.
My gut says that the consumer market feeds their science stuff.
Interesting.
Yeah, I think just because partly like the iteration, they're able to pump out more of the consumer cards because like it doesn't matter if they break and stuff. They have to be really, really tightly controlled on their enterprise level stuff. They can't have graphics cards dying every week. A consumer is just going to buy another one. That's going to piss off somebody because they're losing thousands of dollars every second that thing isn't doing what they built it to do. And the turnover is probably less in the industrial and enterprise solutions. Like they're going to squat on what they have, unless you're in those real high end stuff like AWS. I'm sure they turn over every couple of years or something for their stuff. But
yeah, I always wonder like what happens to those old cards. Like I don't know. Can you still get a V100 on AWS? I don't even know. I guess you probably can. You can probably still get K80s on AWS.
I would think they'd keep some of it around for quite a while, just for if.
But like the demand would for sure like drop, and then I always wonder like they got to be dumping like thousands of these older GPUs.
Right. Oh yeah. Don says I think they must be doing more with machine learning now, but they sell as many consumer cards as they can produce. Yeah. So.
Yeah, that'll have to be a follow-up question then. I really want to know because I always thought like, especially like, I don't know, like 5 years ago, I felt like I was really surprised like companies like AMD did not push really hard for deep learning.
Yeah.
To me, I felt like that's a new market. Like gaming is big. And like as people get it like VR and stuff like that, like the demand for more powerful PCs and stuff is growing. But I just felt like surely like deep learning, scientific computing, and now like scientific computing happens also on like it doesn't have to be deep learning. Like lots of stuff are able to be moved to the GPU to do all your calculations on. So especially like anything big data, it's usually or often better to put it on the GPU if you could.
Right.
So yeah, I always thought that would be the bigger market.
It might have equaled out by now, just with as how popular and big and all the different ways people are manipulating data in a sense. It might now be kind of self-sufficient, but I know for sure, like back in the 10 series, 10 series cards, when the 1080 Ti and stuff were big, that was still their bread and butter. And
the 1080 Ti was like the greatest deep learning card ever. That's the most bang for your buck.
Yeah, and the 2080 Ti as well. Yeah. I know Don has spoken very highly, and like even on into like today, like man, if you got a 2080, you're probably still pretty decent for anything you're trying to do. So, yeah, wow. And I just recently heard that was related to Bitcoin or mining. Intel is coming out with some weird new chip to help with mining operators and stuff and whatever. Man, wow! I feel like we did not even scratch the surface of what we could have talked about today. This was a lot. There's so much we could dive into with this. I really appreciate your time, Harrison. This was really cool.
You too.
Next time, I'm going to definitely have Don join me because I think you guys will just ping off of each other really well, and I can just listen and enjoy.
Yeah.
So
I think the last time I talked with Don, we probably talked for like 25 minutes on, I don't even remember what it was. It was some tangent that we went on. Yeah.
Yeah. And that'll be totally cool. That's all right. So, but man, yes, thank you so much. Before we go, is there anything you'd like to shout out or tell, like how to get into this sort of stuff? Anything you want to mention and tell the audience about?
Yeah, I go plug our book, Neural Networks from Scratch.
Sure.
I'm not sure I would recommend it as like truly an introduction to deep learning, but if you want to learn about deep learning, you could go to pythonprogramming.net, kind of get your feet wet and decide if you want to learn more about how neural networks work. But with Neural Networks from Scratch, the book, we break down every step of neural networks. All you would need to know is like high school level algebra, and like as long as if you know how to multiply two numbers, you should be good. And, cool. And like people like we will show like the algorithm, and people are like, oh no, that looks way too complicated. But truly, like every little step is not complicated. So yeah, if you want to really know like how neural networks work through the forward pass and back propagation, all that, that's definitely something you should check out.
Yeah, and I think I got the right one. It looks correct. The nnfs.io.
Yeah. Thanks for looking that up. Yeah, that's the address.
I try to get that stuff back. Yeah. So again, thank you very much, and I thank the audience as well for joining us. We do this every Wednesday, 1 p.m. Pacific. We bring in a sort of a potpourri of folks on here, but they split down into external experts like Harrison here to kind of talk about, give a little peek behind the curtain of how these things work, how they do what they do, and kind of offer advice and things like that. And then every once in a while, we also bring in our own internal experts to kind of give an idea of how our hardware helps in those sorts of industries. So
I was poking around your podcast. I mean, it looks like there's quite a cool list of talks and stuff. Like it's crazy. Like there's so many podcasts now. It's like it's so hard to like figure out which one that you want to watch, and like soak in. And there's so many like just unbelievably great podcasts out there.
Really are.
Yeah, it's hard. You can't listen to all of them. Yeah, but yeah, I'll definitely have to be tuning into a few more of yours.
Thank you. Awesome. Yeah, that'd be great. So yeah, I think that's it, and that's all. So thanks everybody, and we'll see you all next time.